This movie is intended to give you an understanding of two common principles that govern the algorithmic calculations to choose an attribute to split on at a decision tree node. There are a number of different algorithms for deciding which is the best attribute to split upon. Gini index and error rate are covered in a handout on Moodle, and we're going to focus on Gini index in this movie. You can find them in the single node dtrees handout. Two other important methods are information gain and gain ratio. These algorithms were devised by Quinlan for ID3 and C4.5 decision tree techniques and can be found in the further reading, and by using Google Scholar and by using the University Library to seek out suitable papers. There are two principles that we're interested in. They apply to all the different algorithms. Consider we're building a decision tree. We have a node. We have a set of data that arrives at this node, and it's to be split into subsets at these descendant nodes. We need to choose the best attribute to split on at this node to give us the most pure divisions between, in this case, the two classes of data at the child nodes. So there are two questions we need to consider, two components of the algorithms. First of all, having split up the data, we need to check how good is each of these partitions individually in terms of purity of being weighted towards one class or the other. So basically the number of records of each class that have arrived at these nodes based on that decision. The second question is, how much influence should each of these partitions of the data, each of these nodes, have on the overall decision about splitting on this attribute? Let's consider a distribution of data resulting from a split on a particular attribute. We've got two classes, and suppose we've got 14 of one class and 3 of the other class in here. That's quite a pure split. 5 of one and 27 of the other in here. That's quite a pure split. So each of these nodes looks very good as a result of splitting on that attribute. But if we look at the third node, we've got 531 of one and 549 of the other, almost equally balanced, and a large number of the cases that arrived at this node have arrived at this child node as a result of that split. So the question we must ask is, how do we decide? If we just decided based on that node, we'd say yes, let's split on the attribute. If we decide on that node, we'd say no, we can't split on the attribute. Somehow we have to combine the values of each of these subpartitions to reach an overall decision on how good that attribute is to split compared with other potential attributes. Now we go on to look at numerical processes for doing this for the Gini method, but remember, these two stages or steps or questions apply to all decision tree splitting algorithms.